I feel like I usually say pretty truthfully if I think it's easy or hard. Okay. Okay, awesome. So 3.5 is complex numbers, which is straightforward as heck. We've seen this 10 million times. So, so far in this unit, we've really only been dealing with real numbers and real roots and whatnot, so not imaginary. But now we're going to be looking at all type of complex numbers. So complex numbers have the form a plus bi, where a is the real part of the complex number, and b is the imaginary part of the complex number. So if you think about it, technically, all numbers are complex numbers. So for example, 3 plus 2i is a complex number. 3 would be the real part, 2i would be the imaginary part. Looking at this, even negative 5 is considered a complex number because technically that's negative 5 plus 0i. You guys see how it still has the form a plus bi? So every number is considered a complex number if we're being technical. So 6i is a complex number because that's the same thing as 0 plus 6i, where 0 is the real part, 6i is the imaginary part. So every number is a complex number. So here is the rule. With complex numbers, we can only add real parts with real parts and imaginary parts with imaginary parts, or combine them. And then also remember that I squared equals negative 1, our equivalent statement. So looking at this, it's a complex number added to a complex number. Just because you see parentheses does not mean multiplication, so make sure you look. So then combine real parts with real parts. 3 plus 4 is 7. 5i plus negative 2i is plus 3i. And you always write it as a plus bi form. So pretty easy. We've seen it 10 million times. So this one would be multiplication here. Oh, let's actually do subtraction next. So we would make sure we distribute the negatives. So that's negative 4 plus 2i. And then our front thing didn't change. And then just combine like terms. So 3 minus 4 is negative 1. 5i plus 2i, so that would be plus 7i. Complex numbers are really straightforward. Okay, let's do a multiplication one. So you would distribute because it's multiplication. So 3 times 4 will be 12. 3 times negative 2i is negative 6i. 5i times 4 is positive 20i's. And then positive 5i times negative 2i is usually where people mess up, so be really careful. That's negative 10. I gotta change pens. Apparently this one's sucking today. Yeah. I've had 2 new. This will be my 3rd new one this year. It's in my box right now. That's the thing. I do write hard, but I swear that they're like extra touchy. Anyways. It's not that they're breaking. They get worn down, and then they have like a pointed edge instead of a smooth edge. Anyways. All right. So then looking at this, guys, I would say this is the same thing as minus 10 times negative 1, so that's plus 10. Make sure you don't add them. Don't be that person that adds them. It's times. So that's plus 10. So then 12 plus 10, right, is 22. And then plus 14i. 12 plus 10. And then we have minus 6i plus 20i. And we've taken care of everything. Okay, so we've learned this in 1010. I to the 23rd can be simplified. So we know a couple things. I is I. That would be simplified. Or I squared is negative 1. Those are the 2 things we're going to use for this I to the 23. Can anyone remember by chance in 1010 kind of how we tackled it? So you're changing it so that it all has 2's and 1's, right? The degree. So you said that you thought, Addie, that this is I squared raised to the 11th power, you said, which would be 22. And then times by I, so notice that would be 22, 23 i's. That's a perfect idea. So then from there we have negative 1 to the 11th power times I. So then a negative to an odd will be negative, and then negative I. would be my final answer. So all complex numbers should in the end simplify to be a plus bi. You should not have any I squared or anything like that. Yes? Yeah, well, no, so we changed, this has got to be 23, right? So I squared, right? We always put I squared in here because that's the -1, right?
Oh, okay, I see.
Yeah, and then she said raise it to the 11th because we can't get it to be 23 without putting that extra I there. Awesome. Or 1 or -1. But yeah, actually with the I to the 23, I guess you're right. There could be just 1 or -1 as well. Like I to the 4th, that's -1 times -1. Does that make sense? Okay, awesome. So here's another thing to note. When dividing complex numbers, we want it to not have an I in the denominator. So we don't want imaginary numbers in a denominator, just like we don't like radicals in a denominator. So to get rid of I, we do one of the following things. So here's what you're going to have to just remember. A lot of things to just kind of remember in this unit. So first of all, if you have two terms, to get rid of something, we multiply by the conjugate. So we're going to multiply by 1 plus 2i. Do that to the bottom, you got to do it to the top. 1 plus 2i. So now we're going to distribute out the top. So I'll just make some room. On this side, I'm going to do the top. 3 times 1 is 3. 3 times 2i plus 6i. 5 times 1 plus 5i. Right here, don't be that person that messes this up. So plus 10i squared. Then we have plus 10 times -1. So that's minus 10. So now combine my real parts with my real parts. So that's -7. 6i plus 5i is plus 11i's. So that's our top. Now I'm going to do my bottoms. 1 times 1 is 1. Plus 2i minus 2i. My middle term will cancel out with conjugates. Then right here we have minus 4i squared, which is minus 4 times -1, which is plus 4. So we have a 1 plus 4, which is 5. So now I'd go over here and say divided by 5. Then if all three things divide by something in common, you can simplify it, but this one didn't. Now it's not that we've done something different to the problem, it's just a different form of the same problem without I in the denominator. Okay, well if we only have one term, we don't need to multiply by the conjugate. It's kind of similar to the radical idea. If there's two terms and we have a radical, we have to multiply by the conjugate, but not if there's only one term and a radical. So how could we possibly get rid of I here? Times by I. If you do it to the bottom, you got to do it to the top. And then on top, you have two terms. You need parentheses. You can't just times it to a part of the top. So we would distribute. We don't want to be on the test making the mistakes on the little problems like this, right? This would be really sad to miss any points on something so simple. So we have 7i plus 3i squared on top. So what would that become? 7i minus 3, and then I should reorder it into a plus bi form, so that's -3 plus 7i. Now on bottom, I'm going to have 4 times -1, because I squared is -1. Do you guys see? So then what's 4 times -1? -4. Now technically, if you check your answer in the book, they're not going to leave the negative on bottom. They're going to say divide all this stuff by negative, so then that would be, this is how you'd see it in the book. 3 minus 7i over 4. You see I've just taken and divided both of these by a negative. They don't like negatives in the denominator either. It's not considered simplified. Okay. Okay, so also recall the following. If I squared, so look, if I squared equals -1, isn't it true also that the square root, if we square root both sides, that I is equal to the square root of -1? Yeah, so if we have the square root of -1, that's where we get our imaginary numbers, which we all know all this. It's not new to us. So simplify the following. So right here, that's the same thing as this. The square root of -1 times 16. The square root of -1 is I. The square root of 16 is 4. So we'd write this as 4i. Questions on that? Okay. What would this one become then? I root 7. Don't be that person that pulls out the 7 out of the radical because you pulled the I out of it. 7 had to stay. Now right here we have a negative in front. That's not going to change anything. So negative, and then what am I going to get? Yep, good, 5i. So when you see something like this, guys, what you're going to want to do is say, it says simplify. You'd say, okay, first of all, I have radicals. I would check if any we'll simplify and rewrite those first. So notice the square root of 12 breaks down into 6 times 2, doesn't it? And then that breaks it down into 3 times 2. So we'll pull out a 2. So I'm rewriting this problem. This is 2 root 3 minus what? 2 root 3 minus I root 3. And then I have times 3 plus 2i. And now I can distribute this out. So let's go ahead and do this. Let me give myself some room here. Okay. All right, here we go. 2 root 3's times 3 is 6 root 3's. 2 root 3's times positive 2i's. So everybody, what do you think that would be? 4i root 3. Axel's making some connections. 2 times 2i would be 4i, and then we have a root 3. Now I've distributed 2 root 3 through to everything, so I'll cross it out. So negative I root 3's times 3 would be negative 3i root 3's. Negative I root 3's times positive 2i. Negative 2i squared root 3's. Okay, let's go through and simplify any I squared. So notice right here is an I squared. This is the same thing as negative 2 times negative 1 times root 3. These are all times signs, so don't change them to magic addition signs. So then do you see how a negative times a negative is a positive? So plus 2 root 3's is the exact same thing as that. So now combine things that can be combined. Now remember, radicals have to be like radicals. 2 root 3's plus 6 root 3's is how many root 3's? Yep, 6, 7, 8 root 3's. The apple doesn't change, just like if we were adding 6x plus 2x, 8x. All right, and then aren't these like as well? I root 3's, I root 3's. The apple doesn't change. So 4i root 3's minus 3i root 3's is? Yep, so plus 1i root 3. A plus bi form, so we have it in the correct order. Because the a is the real part, the bi is the imaginary part. Don't be that person that thinks you can combine these. Now the book might do this, and this would not freak you out hopefully at this point. Isn't it true that in each term there's a root 3? So if I really wanted, couldn't I pull out a root 3 and then left would be 8 plus I? This is standard form, this is factor form. Not one is better than the other. So if you see it that way in the book, it's not that their answer is better than yours, it's just written in a different form. Okay. Okay, so solutions of a quadratic that are imaginary or irrational happen when a quadratic cannot be factored. Because remember, if a quadratic can be factored, it'll have whole number roots, whole number solutions, or fractional solutions. Now, if you don't have those type of solutions, quadratics always have 2 solutions. So either they have 2 imaginary solutions or 2 irrational solutions. And you'd have to use the quadratic formula to find them. So we know to solve a quadratic, we put it in standard form, get it set equal to 0, and then we apply the quadratic formula, which, let's pray by now, we all have this memorized. Do I need to give you more time to write it down, or do you have it memorized? Okay, awesome. Okay, so let's just do a couple of these. It says solve the equation. Now let's solve by the most appropriate method, the easiest way for us possible. So with this one, wouldn't it be easiest just to subtract 9? So x squared equals negative 9, then I will square root. When solving, not when simplifying, but when solving, and that's what I'm doing, and taking a square root, I need to do a plus or minus if I take a square root. So I get plus or minus 3i. Now you guys should be able to catch if you forgot that, because degree 2 always has 2 solutions. So if you wrote just 3i, you'd say, what did I forget? Because I need to have 2 of them, 2 solutions. Then hopefully it would kick in. Now look right here. If you tried to factor this one, because once again, we always want to check if it factors. One multiplies to be 5 and adds up to be 4, 1 times 5, and one of them would need to be negative, and that doesn't work. So we would have to do quadratic formula, so let's hurry and do it. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a So that's negative 4 plus or minus the square root. So isn't that 16 minus 20? 16 minus 20 is negative 4 all over 2. So then you have negative 4 plus or minus what? 2i over 2. And then because all three of them divide by 2, I can divide them all by 2. This becomes 1, 2, 1. So we would get negative 2 plus or minus I. There's our two solutions, two imaginary solutions. Okay, I won't go through this one unless you need me to. Could you do the quadratic formula on your own? Okay, and I won't waste your time. Okay, looking at this one, if I said to you, what are the solutions? What would I need to do first? It is not quadratic right now, is it? Okay, what would I need to do first? There's a lot of different ways to tackle it. I'm hearing a few different things. Say again. That's a good thought. But if we get the z's on one side, then that would still kind of be stuck because, I mean, it depends on what your thought process is, I guess. Anyone have a different idea? Not that that would be necessarily wrong, but that's... Guys, this is a rational equation. Rational means fractions. It's a fractional equation. Get a common denominator. Way to remember. So right here, I'm just going to write over 1, over 1, over 1. Okay, everybody good here? Get a common denominator, and then can't we solve using the numerator with rationals? Okay, so we times by z, times by z, times by z, times by z. That has a z, times by z, times by z. So now look, z times z is z squared plus 4z, right? Plus 12, and because I'm solving, I can ignore the denominator, equals, isn't 0 times z 0? So now from here, I would just solve the quadratic. Does that make sense, everyone? So I would say, if it factors, I can solve by factoring. If not, quadratic formula. Do you want me to keep going or not waste your time because you would get it from here? Okay, awesome.
What's the only thing z can't be, though?
Ooh, I didn't even say that. Good point. What is the one solution that we cannot get on this? 0. Good, because that would be a extraneous solution since that would make the denominator 0. Good point. So that would be a solution we would need to throw out, everybody, if you were to get it. That's the end of the lesson for today.